So continuing in the direction of the enforcement with respect to actually knowing where the peers are running, where in this line of work we are focusing not only on having kilometer-wide precision, but ideally being able to pinpoint a particular confidential virtual machine into a particular data center, which comes with different set of requirements that I'll be talking about. And one is like very fresh direction that we are also going to pursuing with respect of the work with space computer in the direction how can we use the satellite-based infrastructure to provide dedicated information for the approved location as well. So the first line of work is focusing on the on-Earth use cases that I would say is a bit more mature, and the motivation for it actually is also slightly different. It's not necessarily focusing on the aspect of geo-decentralization, but rather on how to strengthen the TE's threat model. But the second one, I think, can also go in the direction of strengthening the threat model, but also provide additional guarantees. So the general aspect that we try to focus on is to provide some form of like an aspect of either computation binding to the respective execution environment, which is the work of the data center execution assurance. And the second one is to leverage some of the aspect of communication binding, of knowing that a certain peer is running in a particular location. So similar discussed before with using something like a challenge response, and see how this can be actually used in different contexts. But of course, there are certain type of challenges that we have to resolve. Of course, we assume there can be malicious operators, there can be some network instabilities, and see what can be done in this particular context. So starting with the first work, it's focusing on the on-Earth solution, where we actually are trying to harden the aspect of TE confidential virtual machines that are running in certain respective infrastructure, where the reason for that is, for those are familiar with trusted execution environments, we are facing some challenges with respect to physical attacks and how this can be resolved. So we choose to rely on some aspects of the operator, not trying to physically tamper with the device itself. So then if you look into the details of the TE attestation, doesn't provide any information about the location actually where it's running or the provider either. So we are looking into the ways actually how can we bind these two information together, which eventually basically gives the guarantees that the particular confidential virtual machine is running in, for example, Google Cloud infrastructure, due to the fact that we are able to bind the confidential VM with some additional information coming from the provider. Which the motivation here is mainly on how can we ensure that the TE we are running, integrating with, is basically more secure, where, of course, if you have high value transaction, and you are deploying your sensitive workload inside of the TE, you want to make sure that this is the case. But of course, this also leads to the aspect of getting the confidence about the location where it's actually executed. And for that, we already published initial work that is trying to motivate this particular problem. And we are currently working on a solution that will be hopefully made on an archive later on this month, that is focused on both settings actually of confidential virtual machines that are running inside of a cloud environment, but also on bare metal solutions that are also running in a cloud environment. So the motivation here would be that we are looking for ways and how can we bind the cloud provider details to the trusted execution environment itself. And the way that we envision to do it is to rely actually on the virtual trust platform module that is part of several deployments of cloud providers that is able to later on correlate the information that are coming from the trust execution environment attestation together with the VTPM attestation code, and can later on provide you the guarantees about the particular location where your workload is running. So that part we don't necessarily care about the other external activities, but we know that the particular platform is running in particular data center actually. And we are now rather looking to the other way on how to inject some privacy into the system to make sure that this type of sensitive information about the zone or region where we are deploying your workloads are not leaking, but just provide the information that is running in a trusted environment by the fact of relying on the provider itself. And we have a solution, hopefully, for both bare metal deployments in cloud provider settings, but also for confidential virtual machines, which allows us to have additional trust in the confidential virtual machine that we are interacting with and want to deploy sensitive workloads in them. Of course, here, if you consider it on a large scale, I guess it will basically mean that everyone would have to rely on these which depending on the setting you are interested in might not be completely fitting. And the second direction is very early direction, so bear with us. It's something very fresh that we are working actually also with Dalia in the crowd. So it's more like an open input from community that will be very happy to possibly work on together. Where for those also that do not know us from Space Computer, we are trying to be confidential computing platform running on satellites in space. And we are looking into the ways on how can we provide some of these robust data services to users on Earth. And the idea that we were brainstorming with the team was to look into some solutions, for example, like Goat or similar that are actually aiming to solve the problem of robust file storage on Earth, but try to extend it by leveraging satellite infrastructure. So, but as was pointing out previously, you will need some kind of like a assumption on the hardware that may be available on the device, on the terminal on Earth, because otherwise GPS spoofing and other situations are very, very easily. So can we do something without TEs, or do we always need some type of TEs on Earth that will basically prevent it? Or can we just design a general purpose challenge response protocol when we are interacting with the peers on Earth? And maybe argue that also due to the physical location that when we are communicating with a particle here, they have to, of course, be within the reach of the satellite, and this basically provide us some additional guarantees as well. So there are, I think, few open questions that in general, of course, we know from the part of typical satellite communication in the context of GPS, as we know, but this is something that will require, for example, terminals running on in the infrastructure itself, which might even be actually suitable for applications like data centers, because if you look at it, many of the data centers nowadays are already relying on running dedicated network interface cards, for example, for solutions like Precision Time Protocol or TPP, where they're actually getting very precise clocks from space-based infrastructure to be able to synchronize their wall clocks using Precision Time Protocol, for which they actually have a dedicated hardware already in their infrastructure. So then you just need to extend it by additional aspects of the GPS location with respect to triangulate into a particular area. And then the cloud providers themselves can actually provide it for the individual peers in the system. So I know that, for example, Meta is using this very actively in their infrastructure already because they, of course, are interested, for example, for logging when certain informations are coming in, but it's also being used quite actively in TradeFi with respect to data centers as well. So is there a way on how to extend on this type of assumptions to get better understanding? Or the other way around, there's already a lot of current infrastructure for space-based communication, either relays or other type of infrastructure that is around the world. And we can try to map it out and see basically what are the latencies between the individual base stations and gateways on Earth, and later on how to triangulate or use some improved location with the respective of the peers on Earth. That will be orchestrated through the information that we are gathering. So this was a lightning talk. It's nothing that it's fully set in stone. I just wanted to provide some possible direction where we have different set of assumptions on the computational solutions. We are relying heavily on, of course, TEs with respect to the confidentiality, but also the VTPs that are providing us the root of trust coming from the cloud provider. But of course, in case we want to have a robust and temper-resistant solutions for the satellite infrastructure, we also have to consider some form of capabilities by the provider that can maybe try to spoof the information that are coming out of the respective devices, or we have to maybe put some trust in the respective infrastructure provider. But maybe if we find actually an interesting direction, that could be something, an interesting questions we are currently working on is actually, is there some there is basically instead of proving location on Earth, can you actually try to prove the satellites in space that will inherently maybe also be able to bridge the gap between the location on Earth, because you have to be able to communicate with the satellite at a respective point in time that actually can disclose the information about your particular location. So I think there are interesting direction that could be pursued for both of the computation binding, but also for the communication one. Yeah, that's pretty much end of my talk. Thank you very much. Questions? Yes.
So for the data centers, basically you will use the antenna which is like on the roof and like connect your own like special device.
That could be one possible setting. It will of course require the communication or extension by respective data center provider, or it's more likely maybe that the provider itself is just having data and then they are providing this information as a service to the individual peers.
And like when you say the information, you mean information like the time, like from GPS?
Exactly, yeah. Exactly.
Okay.
So this is, for example, the current setting for the precision time protocol. You have a dedicated network interface card for which you have a GPS receiver. And then internally inside of the data center, they have infrastructure that is PTP capable, meaning actually that you really are able to synchronize your clocks in nanosecond precision, and they're distributing this clock information to the peers in the system. But of course, it assumes that the peers are honest, right, in this context. But since it's usually provided to you on the host operating system level, and maybe it's like even like a single provider, you can have similar enough assumptions on the front. But of course, if you go into the malicious scenarios where the parties can just delay the responses or whatever they want, then it's
Rhonda, in your slides, it said GPS can be spoofed. Does this? Can you guys reconcile? It seems like there's a. I just read GPS can be spoofed. This feels like GPS, so now I'm curious.
So a way you can spoof GPS is. So the way GPS works is some timestamps. GPS try to release some timestamps. And then you say calculate your delay based on 4 timestamps. So you collect 4 timestamps to determine your own time and your location. You just artificially manipulate those timestamps. You capture it early or later in time and then release it to the receiver after a certain delay. And that's how you spoof it.
Could you just make the explicit connection?
Yeah, so basically here you wouldn't be relying on timestamp, on the GPS itself, like as a protocol, because as mentioned, like it doesn't provide too much security with respect to it, but you would have to be using maybe our infrastructure or our like infrastructure with respect to providing confidential, then we of course would assume that there would be some form of trusted element possibly on the device itself.
So you're replacing GPS with like a TE on both sides of the
Exactly.
Yeah.
So you can have a physical layer in between, which is spoof.
Why do you need a TE on the ground? Wouldn't it be sufficient just to have TEs in space doing the triangulation?
But then the peer itself can just do whatever they want with the information they're receiving. They could try to either modify the timestamp directly, right, or just not.
You can measure the response time back to the satellite, right? Or that doesn't work. You can't respond back.
Then you will get, I think, you get some guarantees, right? But it will be still either is it the upper bound, right? You would have to, you would have to kind of consider, I think, the settings you're relying on. You would get some information, but then I think still the setting could, in this case, could be that maybe I'm just like using something like a VPN to run and claim that I'm in this particular location to challenge. So if you want to get a confidence that your particular workload is also running at this particular location as well.
You could also like pull in proofs from like different places and like assemble like, say like, okay, this is my GPS, but you've collected timestamps at like 6 months and forwarded them.
Yeah. So you need to have also some confidence, I think, in the end nodes as well.
Yeah, I won't.
Yeah.
That's one question.
Anyone else? It's kind of a troll, but a consistent flash boss troll. But what about putting one in a volcano to you?
Good question.
Let's go.
Let's go, you know? It might be easier. You don't have to worry about the space radiation, but you have to worry about the shielding for the temperature.
Yes,
Maybe it's easier.
Well, there's also one in a carbon fiber sub right next to the Titanic. Yes. Very robust and tamper-proof. Yeah. No,
It kind of improved, right?
Yeah. But okay, actually, serious question on implementation. So, whoever you're using to launch the satellite, sorry, this is just today.
Mm-hmm.
You know, end game. I'm sure you're launching your own. Can they control your device and all? Like, is this like are they like a hypervisor to your machine? You give them to launch into space.
You mean like just with the satellite?
Yeah, with the satellite. Yeah.
I mean, there are different models. So currently what is becoming more popular it's like basically software as a service. So you can just like rent a compute, but you can also like still own the aspect of the infrastructure and the satellite itself. Then you control the host operating system, VM, whatever you want as well. So there are different solutions, different settings.
Okay.
You can also have like a multi-tenancy. Basically, it's like the tendency is towards like a cloud-based deployment, so you can just like run your virtual machine easily on satellite in space. So, for example, companies like StarCloud or others are really trying to provide this type of environment.
Okay. Yeah, I guess I was just wondering to what extent like software side channels.
Yeah, it's a problem. Yeah. Definitely for that, I think you need that's the part we are looking into, like a layered approach of having dedicated TE on the satellite itself that will be leveraging just the physical isolation to strengthen the threat model of software.
Not really a good question. I'm just curious because you might know what's the law about code in space.
To our knowledge, currently, I think there is not much of a law regarding that. Yeah, just claiming it.
So every signal captured in orbit from Earth, you have to store it, and if you're emitting it back to Earth, you have to store it for at least 7 years, I think. You cannot delete it. So you have to be very choosy about what you transmit back to Earth. This is a big problem for companies like Planet that maps the entire Earth, but most of their pictures are just clouds if they don't see through them. If they send it back to Earth, they have to keep the exabytes of the data. I don't know that there's any regulation regarding code.
Sounding makes sense.
Asking your person.
Yeah.
Thank you very much.